Algebra 2, Concept 13, Teacher Talk, Classifying and Evaluating Polynomials. So let's start with first just the definition of a polynomial. So we're going to look at each of these examples and decide whether it is a polynomial. If it is, then we're going to write it in standard form, state its degree, its type, and its leading coefficient, and then we'll classify each polynomial by its number of terms. All those characteristics of polynomials are good to know moving forward to figure out how to graph the function and just how the function works. So remember, with a polynomial, we're looking for two things for it to fit the definition of a polynomial. First of all, that we've got whole number exponents. So that means an exponent can be 0, but then also positive whole numbers. And then the second thing is that all of the coefficients are real numbers. That's pretty much any number that you normally work with on a regular basis. You just don't want any imaginary. So number one, we look at our exponents and we look at our coefficients and we see whole numbers and real numbers. So yes, number one is a polynomial. But if you look at the exponents, you'll see it's not in standard form. So let's rewrite it. And we'll put the term with the biggest exponent first and then work our way down. Now we can easily pick out the degree, which is 3, and that is a cubic. And then if we have it in standard form, we can look at the coefficient that's first, and that's our leading coefficient. This one has 4 terms, so in that case, to classify it for its number of terms, 4 or greater, we simply say a polynomial. And our leading coefficient is positive 5. Now look at number 2. Do you see what I see? Yep, a negative exponent. That is not a whole number, so that makes this equation not fit the definition of a polynomial. And then we're going to move on. So number 3 says evaluate the functions for the given value of x. And on 3 we're going to use direct substitution, which means that you're going to plug in -1 for x. So we'll have -2 times -1 to the 4th plus -1 to the 3rd plus 5 times -1 squared minus 3 times -1 minus 7. So you want to do those exponent first. So it would be +1 times 2, which is -2. -1 to the 3rd power is -1. We'll end up with +5 plus 3 minus 7. And then if you work left to right, you'll see that when you plug in -1, you'll get -2. And notice how we write that final answer in function notation. And we read it as f of -1 equals -2. That gives us a record of what we've done, what we have plugged in, and then what number we had as a result. Now in 4, we're going to use that neat method of synthetic substitution. So this is a process where, first of all, you look at your polynomial and look at it in standard form and say, am I missing any exponent terms? Well, on this one, hopefully you'll notice you're missing an x squared term. So for this process, we'll have to put in a 0 placeholder for the coefficient of x squared. So let's pull those coefficients off, and we're going to space them across our paper. Notice I put a 0 in the place of where the x squared should be. And then we draw, it's like an upside down old-timey division, and out to the side we put the number that we are substituting in. The process works if you remember, you bring the first number down, you multiply diagonally and add vertically. Multiply and then add, multiply and add, multiply and add. Our final answer in the row is our value that we get when we plug our given value, in this case -6, into the function. And so we can write that in function notation, that g of -6 equals 6,848. Now here's an application of polynomials. So the weight of an ideal round cut diamond can be modeled by, and there's the equation where W is the weight in carats and D is the diameter in millimeters. So according to the model, that means that math equation, what is the weight of a diamond with a diameter of 12 meters? Sorry, millimeters. That would be crazy. So you want to take 12 and plug it in for D. Remember, when we do the math, the exponents come first, but actually I would just grab your calculator in, and if you're careful, plug in all your numbers at once and press enter, and your calculator will do everything for you in the right order. Exponents first, then multiplication, and then addition and subtraction left to right. So this would be if we round to tens place, a diamond that is approximately 8.5 carats. Whoa. All right, that concludes the teacher talk highlighting the important concepts on number concept 13, just classifying polynomials and evaluating polynomials.